Hey, welcome back. Today on my bench I have a treat. This is a Luxman AM/FM stereo tuner, the R-5030. Nice slim design. I don't know if you noticed, in the 70s they had the big chunky aluminum extruded fronts on the stereos, and I guess that was a symbol of status to have that big shiny aluminum front on a stereo. But then when the 80s came along, how dirty this is. When the 80s came along, everybody, the trend was, let's make them really slim and sleek, and this is no exception. They scaled it down. It's a heavy unit. It's got quite a bit of weight to it, considering its size. And then the trend went from slim silver fronts to slim black fronts. I don't know if you remember that. Yeah, everybody had to go have their black face stereos, and then from there it turned into well, we all know it went into surround sound and all those of that time. But nice unit, nice clean unit. Well, it's dirty, but it's like a bull in a china shop here. It's not damaged. It's just dirty. It's got these funky piano keys on them. You can't really tell what position the switch is in from looking at it. There's no, I don't think there's any indicator. No, there's no lights or indicators, so you have to kind of guess which one it's pressed in. It's basically just like everybody else. Volume control, loudness, variable loudness, which is a nice feature, because I don't always like the way the loudness contour is set up. This one has a cat tuner. It's cat for computer aided tuning, I believe it's called, and it's got a special thing in the tuning circuit that helps the tuner pull the station in, get a better signal, and then it's got dual beta circuit, whatever that means, don't know. But this was purchased for a good amount, for me anyway, because it's on the assumption it doesn't work. I think it's one channel is out, and what I'm going to do right now is I'm going to plug it in, and we're going to test the DC offset on the outputs. Make sure that we're not pumping out 40 volts DC onto a speaker. So let's do this first. Okay, is this going to work? I might not even be able to reach with my probe. I'm going to have to take the top off. Bear with me. This is my first Luxman I've had on my bench, and I kind of like it. It says Ultimate Fidelity by Stereo Component by Lux Corporation. Let's have a look inside. What fell? It's like a roll of tape. Okay. One thing I couldn't figure out about this Luxman is the ventilation is all on the right hand side here, and it's directly over the tuner. You can see all the garbage and junk. Look at it, how filthy that is. And then on the other side, where there's no ventilation, they have the power amplifier and the power supply. Interesting. How filthy that is. I'm definitely going to have to blow this out with air. It's plugged in. I can't really see the fuses, they're so dirty. Let's try this. plugged in, yes. I got no lights. We're drawing 23 watts. I think I might have blown fuses in here. They're hard to see. I'm going to have to 5, 6, 7 fuses total. Okay, this fuse is good. We know that because it draws 20 some watts. This is a 3.5 amp. That's correct. These are speaker fuses back here, I believe. Can't get it out. Incredibly hard to see. Okay, this one's good. Wow. Two amp fuses for the speakers. They're both good. Somebody removed the pilot light bulb, or the tuning bulb. I guess it goes here somewhere. So we'll have to address that. 4 more fuses to check. That one's good, and that is a 2.5 amp. Come on, behave. This one's blown, but that might have been me just now. Let's try. This one's good. .5 amps. Okay. The last one. It's good. Okay. So I'll replace that one 2.5 amp, and we'll get on to doing some testing here. Alright, so let's go through and let's measure the DC offset on the output of the amplifier, both amplifiers, and we'll see exactly what's going on there. Let's get this set up so you can see it. Can you see it here? Yeah, you should see that. Okay, let's turn this on. It was plugged in. Let's test this channel. And we got 14 millivolts there. That's good. Let's check the other channel. And we got 2. Let me see. Let's shut this off and see if that drops to 0. Yes. Okay. Get the power on thump, and then it kind of settles around 2 millivolts. Alright, so I have a feeling there's really nothing wrong with these power amplifiers. I'm kind of curious as to what's wrong with this thing, as it said it came in with 1 dead channel. I'm going to go back and check that. If it's got 1 dead channel, could be a lot of different things, but let me go back and see what the original complaint was. Okay, so I went back and checked with the previous owner, and what they said was the left channel has a lot of staticky sounds. The right channel needs adjusting as well. I don't know what he means by that. And then it says missing a lot of the high ends of the music. So that right there tells me that's caps, but could be anything. So let's hook this up to a set of speakers and give it a test drive and see. We can do that right now. Let's see. It's got right channel, left channel. So we're plugged in right now. How does this work? Speaker A, right, left. Okay. Right here. Clip this in. Clip this in. And where's my left channel? These cheap Chinese alligator clips, I just hate them. I'd like to find a good source of decent alligator clips without paying through my nose. Okay. Speakers hooked. Let's try this out. What are we on? AM. Turn off speaker B. Tape 1 and 2. Okay. We're not picking up any AM. You have no antenna. At least we know the AM's working. Okay, let's hook up an antenna. Let's go AM. Ooh. Wow. I don't know if you can see this, but I got 5 LEDs lit up here. And I'm getting nothing with the AM. Something's wrong. Yeah, it's buggered. Okay, let's try FM. Okay, turn it back on, FM. I'm on FM. Phono hum. I'm getting no FM at all. It's dead. Oh, we got some work ahead of us. But the amplifiers are working. So let's feed a signal in and see what they're talking about, distortion and whatnot. Alright, There is no auxiliary input on this thing, so I am feeding a signal into tape 1. Yes, we know. Right channel, left channel. Seems like there's a bit of distortion on the left channel. Let's change our frequency. I'm getting equal output from both channels, it seems. So I don't know, I'm at a kind of a loss here as to what's wrong with the amplifier. Doesn't seem like there's much wrong with it. Main problem is there's no FM, no AM. Okay, well, let's take off the bottom and have a look at the underside. Maybe there's some bad solder connections that's giving us grief. They built this slim design, and they really were cramped for space. So what they did is they mounted the power transformer right on the bottom pan. So I pulled the screws for the power transformer, and it's kind of flopping in the wind there. You can see that. It looks like we might have a liquid spill here. But this power transformer's just barely in there, so okay. Not much to see under here. It's all looks like somebody might have resoldered this. The tuner section I'll deal with after. Let's get the power amplifier working properly first. I blew the dust out of this thing, and it was just incredible the amount of dust that was over the tuner. It was caked in there heavy, and I have a suspicion that maybe something got shorted with dust. I don't know, but we'll figure this out. But let's have a good look at this bottom printed circuit board here. It has discrete outputs, and it has also, it's an STK 3042 Mark III, and this is a driver chip. I hope that's not bad because I probably don't have another one of those. Rubicon caps everywhere. They look good. I do see some circuit glue here around the power supply. I had some corrosion going on with a few of these jumpers, so I'll clean that up. I'll have to pull these caps out and clean these up. And that's the only spot I see circuit glue. The rest of it looks pretty clean. And Rubicon caps, like I said, everywhere. But that doesn't mean anything, considering this thing is 1980, 84, I'm guessing. Let's see if we can find a date code. Find a date code somewhere. I'm not seeing anything. These switches here, they run through this braided, it's not a cable, it's a mechanical push-pull thing, and then the switch is right here. And I believe these are removable. I think you can just pull these off if they're clipped on. I don't want to break it, but a lot of dust in here. Inside you can see the metal strip is moving. And I think as the dust gets in there, it kind of slows things down. Here's another one. This one's really stiff. Okay, well, it seems like a good design. Like they have the capacitors back away from the heat sinking. They use quality components for sure, and everything looks intact. It doesn't look like it's been serviced. So let's figure out what's going on with this thing. Okay, I'm just going through my inspection here, and I'm finding something. Not very big deal though. This is the tuning capacitor here, the underside of it. And there's 1, 2, 3, 4, 5 areas where they soldered the capacitor down. This one here is cracked. The connection's cracked, but also the board is cracked too. The board must have took a hit or a drop, and it's cracked from here. Oh, where does it go? It's all the way to here. This is about 3/4 of an inch long there. And then there's another crack coming from the other side. It goes through the board, and it might be through that one trace there. I'm not sure. It kind of ends right there at that trace. So I'm going to jumper this trace and solder this back up. But that board is definitely cracked and broken. But this is all ground plane here, so it doesn't really matter. It's not critical. But I'm going to have to keep my eyes open for more. See, here's a post. I have to check around here for cracks. If it took a drop or a hit, it could be cracks or broken PCBs anywhere on this thing. So you just got to be aware of that. Yeah, I'm just trying to solder this, and it's such a massive metal. It doesn't want to. I'm just going to crank my iron up to max, and then we'll see if we can get this. Let this heat up. You got a little thermal mass. It doesn't want to. Just got to put the iron on there and let it cook. This copper ground plane here it's really absorbs the heat. Come on, you're almost there. Okay, I'll leave it at that. Let me do this one as well. This one's cracked as well, but it's not as bad as the other one. It's got a fine solder crack. That's with my iron cranked up to the max. Okay, I'll leave that one. Alright, I just want to go through and check the power supply. There's a cable that runs from the power supply board over to the FM AM tuner board. This cable here, this connector. And I just want to make sure all the voltages are there. We don't have a power supply problem. So let's look at some of these. Brown is minus 24 volts. Turn this. Okay, minus 24 volts. That's correct. Red is minus 23 volts. And we have about 12. So I don't know if that's right. Minus 23. Orange is plus 55. Orange. What's going on with orange? plus 56 volts on orange. No, plus 5.6, sorry. And we got a negative voltage there. We have negative 35 volts on the orange wire. Is that right? No, that's not right. That should be plus 5. So something's wrong there. Yellow wire, plus 31. Let's turn this down. Yellow wire, plus 31, yep. Green wires, plus 13. And we got 14 volts. Blue wires, plus 24. And we got 25. So there's something definitely wrong with the plus 5.6 volt supply. And that might be the problem, the reason why we have no FM or no AM working properly. So let's go investigate that. That's all right here in this little area. This transistor, series pass transistor, what's it called? Q817. It is a D2SD880. I found a couple of cracked solder joints on it, but it shouldn't be causing that problem. So I think we got maybe a bad zener or something's going on here. So let's look deeper into this. Okay, here's the power supply circuit. And here's the voltages I was reading off the PCB board. And the one here, the orange wire, is supposed to be 5.6 volts. So when I'm not getting a right voltage, I checked these 3 Zener diodes, they seem okay. I checked these fusible resistors, they seem okay. I checked these transistors, I'm really not sure about. I'd have to remove them from the circuit. But the thing is, I'm finding this, see this circuit glue here? You can see that. And let's see here, where else was it? Oh yeah, down here. You see this circuit glue? It's all corroding this jumper. I'm going to remove these caps. I'm going to remove these caps, remove all the circuit glue, and then I'm going to start my troubleshooting even before I attempt to do anything around here. But hopefully it's just a little power supply issue, and then we can fix it and get this thing going. Okay, I pretty much rebuilt the entire power supply here. I recapped it with new caps. I took out the old ones. They didn't test bad, but you know, they were covered with the some of the caps are covered with the circuit glue, so I didn't bother picking that off. I just put a new cap in and checked out all the semiconductors. Everything's good. Now, what threw me the first time around is the silk screening on this board is wrong. It has some incorrect voltages printed on there. I have, on the schematic diagram, I have plus minus 24 volts, which I do have here, plus minus 13 volts. I have plus 13, but I have minus 23, so that's a typo. And I have plus minus 31 volts. And I got plus 31, but minus 31 should actually be printed on there instead of 5.6. So this is wrong. That's what threw me off. So all the voltages are correct. Now, I'm looking at the rest of this. Oh, another thing I did. You can see these caps up here. These 2 caps. I put those, replaced those as well. These are the, I don't know if you know about these, the RIFA caps. Dave Jones did a video on these RIFA caps about how they fail. I wasn't concerned about these caps failing because they're on the secondary side and they're relatively low voltage. But these ones, I pulled them out and looked at them, and they do have the classic cracking on the sides. You know, they crack open on the sides and then moisture gets in and then they just explode on you once they, this one's worse. So I just decided to yank these 2 caps. They're 0.01 microfarad RIFA caps, and I put regular, actually these are really high quality caps I got from a server power supply, and these are rated at 400 volts AC, so they will never give up, those 2. Now on to the main electrolytics. I put these on my tester, and they came out both at exactly 6800 microfarads. So these are bang on. These are good Rubicon quality caps. I'm going to put these back in, and we're going to go with them again. There's nothing wrong with them whatsoever. Pretty good. Now I'm trying to figure out why I don't have FM and AM, and I'm looking at the boards here, and I had a big liquid spill here. I can't see it. Let me crank this down so you can see better. This whole section here has crusty residue mixed in with the dust, and this is the AM section right here. And it's got a chip. It's a, let me get the dust off so I can read it. It's an LA1240, which is your all-in-one AM radio chip. It's got the RF amplifier, it's got intermediate frequency. Everything's done in this one chip, and then you got your support circuitry around it, your caps and your resistors. So I'm going to have to take this all apart here. I think I might have to clean it. Maybe that chip is bad, I don't know. But there is a lot of stuff stuck to the board, which may be conductive. So I'll get that working. The FM portion I haven't even looked at yet. But I did go and I looked over the bottom of the board, did a lot of cleaning, and did a lot of soldering on questionable joints. I didn't find any cracked solder joints, but I did find some that looked kind of questionable, so I touched them up. But for right now, I want to get this AM working, and since it's a single chip solution, I think there might be a problem. If the spill got into the banana slicer here, it might be a problem, but I'll go through and check that out. Anything else? I think I covered it all. So I'll get you another update when I get back. And I'm also looking at this, I'm going to retrofit an LED in here. There was a bulb inside here, and it looks like it illuminates the front tuning indicator. So I'm probably going to put a warm white or a cold, warm white LED in there, and just call her a day. I think, from what I can see here, pull this out if I can. It's stuck in there pretty good. Come on. Is it glued in? I don't know. Ooh, that didn't sound good. There's a blue condom stuck in there, so I'm just curious as to the color of the light. If I can go, I don't want to go with the blue LED. Blue LEDs are too overpowering. Let me think about that. Maybe I'll do something unique. Alright, just giving the AM one more test. I put on a loop antenna, and it seems to be working now. I did some cleaning around the chip here. I'm going to do some more. But it's...
When we imposed the lockdown, the disease was already too widespread for it to be
18 influenza.
David Show. 9:30.
Now it's time to get the FM working. Let's see if I can figure this out. FM is this one. And I got nothing. Absolutely nothing. So I'm going to go through this. This is all FM section here, and I'm going to go through it and make sure it's all 100%. Alright, I think I pinpointed the problem with the FM tuner. This chip here, this LA-1235, is not passing a signal. I fed it a 10.7 megahertz intermediate frequency signal, and it's totally deaf. If I go on the chip pin, what is it, 6? Yeah, let's try pin 6. So try here. If I touch it with my finger, yeah, pin 6. I don't know if you can hear that, but getting a 60 cycle hum when I touch pin 6, which is an audio signal coming out of that chip, and I'm substituting my pretty sure that chip is dead. And I scoped the input to that chip, and I'm getting, as I tune, I'm getting frequencies, I'm getting channels tuning in. So that's the end of that one. I'm gonna have to look through my inventory and see. I don't have one listed in my stock, but I might have one on a board somewhere that I could pull. But I'm gonna look for that chip. If I can't find it, I'm going to order it, and then we're gonna put it in. All right, let's do some testing here. I got it all wired into my dummy load, and scope hooked up, AC voltmeter hooked up, and let's turn it on. Turn it on. Now, I got a 1000 hertz signal feeding in. Just want to check some of the controls here. Balance. That's the, what was that? The treble, bass. Everything hot, sound clean. Now, I just want to talk a bit about setting this thing up on the bias and the DC offset. The DC offset was pretty simple. You hook up a voltmeter to the output speaker terminals and do one channel at a time, and then you set, there's two pots here, VR803B and VR803A, those two pots up front, and they set the DC offset for the channel, and you set that to 0. That's fine and dandy, but the fun starts where you have to do the bias adjustments. If you go through the manual, it gives you instructions here on the second page or first page on the bottom, how to set the bias, and it's pretty unconventional from what we're used to doing. Normally we measure across the emitter resistor with a voltmeter. We measure the current flow through it with a voltmeter, then we, through calculations, we know how much current we have going through those output transistors. But this is a little different. What they want you to do is yank one of the fuses for either the left or right channel and hook up an ammeter in its place where the fuse was. Turn it on, let it settle for 5 minutes or so, and then you adjust the trim pot for 50 milliamps current draw on that power amplifier for that channel, which is kind of, I don't understand why they do that, because you're not measuring the current just through those transistors anymore. You're measuring the current for the entire circuit, and they specify 50 milliamps, which sets the amplifier up for the correct amount of bias. I think it would have been better if they went with the conventional method of measuring emitter resistors and going that way, but hey, what do I know? So it's all been adjusted and we're ready to go. So we got 1000 hertz tone. Let's shut off the speakers and focus on the scope, and I'll take this up to clipping right there. And we got 19.6 volts on the output. The specification for this amplifier is 35 watts per channel. Yeah. Okay, let's take it down. Let's increase the frequency to 20 kilohertz. K. It does look like the left channel is lower than the right. Maybe a little bit. There's clipping there. And we're at 19.2, so it's pretty consistent. I want to see how these two channels track together. They're doing okay. Equal volume. Okay, let's see here. It says in the specs that this thing is flat up to 70. What? That must be a typo. It says 10 hertz to 70 hertz plus minus 1 dB. Yeah, that's got to be a typo. Let's see right here. Frequency response 10 hertz to 70 hertz. It's not very good. Let's try this one. Yeah, this one's right. 10 hertz to 70 kilohertz. So let's crank this up to 70 kilohertz. And let's turn it up. Right there, and I got 17.6 volts RMS. It's pretty good. Pretty good little amplifier. So it does the business. That's what we want. I don't want to cook this thing too long. Pretty good. Pretty good. Here's a look at some of the parts I changed out. The Rubicon caps. These caps still test good, but like I said, I didn't want to bother picking that brown snot off the caps. And then I just went ahead and changed a few more out in the power supply. Power supply has completely been recapped. These two Rifa caps, I took them out just because they're garbage. And of course we have a little incandescent bulb that burned out. Alright, so that's it for this video. Got it all back together. That's as far as I'm going to take this one on this video, because we're still waiting for parts for the FM circuits. And when the parts do come back, I'll revisit this receiver and we'll finish repair on the FM. But yeah, I like these little Luxmans. It's a pretty nice little unit, and it's got a nice build quality. It's designed well. It has its quirkiness, but it's good. If you can see that, I put in a UV LED for the light. It's not a bright blue, but it's more of a subdued, and I think it shows up different on the camera than it does in real life. I think it's a little brighter on the camera, but that's okay. But it's a nice unit, and you know, I enjoyed working on it. It's got a lot of good things about this. So yeah, it's nice. One thing I'm not big on is the ventilation. Got the ventilation on the right hand side over top of the tuner, and all that dust and crap got in there. And the ventilation on the bottom is on the left hand side, so the air has to come up through here, travel across and go out. I'm not a big fan of that. Heat doesn't like to travel sideways, and you can see here there's ventilation on this side too, but yeah, like I said, heat doesn't like to travel sideways, it wants to go straight up. So they should have put some ventilation above the power amp. It's a heavy little unit, 35 watts a channel. It's a nice little rig. I'm going to look forward to listening to it. Alright, that's it for today. Thanks for watching. Peace out.